it's time to start again. I hope that most of you are back from the break. I'd like to remind you that we do have a Q&A document that you all got by email and was shared in the chat. It is okay to write questions in the Zoom chat if you really want to, and then we'll move them there. And I'll try to make time so that you get to ask your questions live as well. And we'll remove that from the recording. But then it's best you wait until I ask you. So then you find the lecture I'll go through on the course webpage, traversing the commit tree. And I'm going to modify this. Oh yeah, modify this window a bit so that you get to focus on this material. If the font is not big enough, please let me know. Yes, it's okay. So I will mostly be following the material which is on the course page. I will not use the terminal so much today. But if I need to explain something, then yeah, we can always do that. So commits. What I will focus in this lecture is how we can investigate commits, how we can compare commits that have been done at different points in time, how we can modify commits. But we'll start with investigating history. So the command that is to be used to see our commit tree is the git log command. And this is one of the most used commands in Git. And it has many different options. And I will just remind you from the previous lectures, actually the lecture that Pedro had, is that you can check all the options to be used with a different command by either doing git help and then the command. So let's say in this case log, then you're going to get from many different options, which can be actually a bit overwhelming, as many of these manual pages are, especially for Git. Alternatively, you can do man git, and then again with the git command log, it's the same output actually. And then you exit this in my case with Q. But this is a bit overwhelming, so I will also show you the official webpage for Git, which is, let's go back to the browser, gitscm.com. And you can find here, maybe some of you actually recognize these pages. You can install Git this way. But I want to point out that there is also an electronic version of this ProGit book. But let me just show you actually how you can get more info on a certain command. So let's type, for example, git log again. Let's assume that this is what I want to learn. So you can see all the reference that the manual pages in the terminal showed in a slightly different format, but the information is more or less the same. The advantage is that this is a little bit more readable, but still overwhelming. So another thing that you can do is actually to search for a certain command or some other keyword, but look at the hits that are in the book. And this is a little bit more beginner friendly, as it gives you some well, easier to comprehend examples. This was, yeah, depends a little bit on the command, but again, you can type git log or whatever, git status, and then you can look at different chapters in the book. Okay, but back to our lesson material. So again, the history of all our commits can be investigated with this git log command. And if we just use it as it is, git log, it's going to show all the commits starting from the latest one, or well, the one where the head is pointing to, and all its parents. So in this case, the latest commit had this particular hash, and the head is pointing to this hash, and also the tip of the master branch. So we have a reference associated with this commit, which is actually we have two references. It's the head reference and it is the master branch reference. We get information on the person that has committed this commit, and then the date when this was done, followed by the commit message. In this case, it is only one line, but it can be longer than this. Usually the entire, so git log without any other particular options is going to list the entire commit message. In this case, well, this commit does have a parent commit, so and the git log by default will show, well, the latest commit and then all its parents commits. So if we use a different reference than the default head, then git log is going to list all the commits that are reachable from that reference. And what can this reference be? It can either be a commit hash, well, the full of it, or a part of the commit hash. It can also be a branch reference, or it can also be a tag. And Brigitte showed how you can define some tags, and we'll go through that a bit in more detail in this lecture. So in this example here, instead of using git log, which by default means git log head, I have chosen a part of a commit hash, and then I get the information on that particular commit and all its parents. In this case, there were just two commits, which were reachable from this D91. Okay, but git log can be used with many different options. So I'm going to give you some more examples. One useful one is the -n option, which is short for number. So it can be minus number or -n. And this is going to list only a given number of the most recent commits. Again, it should be used with a reference. If no reference is given, then it will take the head as default. And when is this option -n useful? So this is especially useful if you have hundreds of commits in a repository and you're only interested in, let's say, 10 latest ones or something like that. So particularly useful for very large repositories. Now, if the commit messages are very long, and it is useful actually to have substantial commit messages so that your collaborators and you in the future know what has been introduced in different commits. But sometimes, I mean, it can be overwhelming to get all this information with git log. There is one very good option that you can use with that, and it's very popular, the --1 line. So what one line does is to reformat the output of the git log command so that you only get one line per commit. So in this case, it's going to give a shortened hash. It's going to show the references which are associated with that hash, in this case head, and the tip of the master branch that the head is pointing to, and then the very first line of the commit message. So and then as before, it's going to show all the commits which are reachable from this particular head commit in this case. So the parent commit of 84, which is D9, and then in its turn, the parent of D9, so the grandparent of the 84 commit, which is this third most recent commit. And so on if they are more ancestors of this 84 commit. There are other options that you can use instead of just one line. You can also use it this way. So -- format equal the format that you want to be used. And then again, the reference, again, this can be a commit hash, it can be head, it can be a branch or a tag. And if none is given, then head is taken. And different formats include one line and short, medium, and so on. I find it most particular, the one line one. If you are searching for something in particular in your commits, let's say that you want to find some bug fix or a function that has been introduced at a given time, then you can use git log with regular expressions. So a regular expression is, for those of you that don't remember, is just a sequence of characters that define a search pattern. So we want to define a search pattern that can search through our commit messages. And to do that, we have git log followed up by the option --grep, and then the value of this regular expression. And again, the reference for the commit. In this case, a very simple example, we want to find commits that have the word bug in the commit message, somewhere in the commit message. And git log will search only through these commit messages. Okay, in this case, it found one, and then it prints the information about this commit, like the hash, author, and the date. And typically, well, the full commit message, in this case, it has just been one line. Okay, let's assume that you have been on vacation for a while, and then you know, okay, what has been done while you were away. And this is especially useful with repositories that you work collaboratively with. You can use git log with dates. You can specify, for example, before or after a certain date. In this case, git log will print, for example, all the commits that have been done after the end of May, but before June 15. And there are different formats in which you can specify these after and before values. Okay. What we are usually interested in is not just to see, I mean, when commits have been done, but also what the files have been modified at in different commits. So we can use git log with additional options so that it also displays the files that have been changed in the different commits. We do that with -- name status, and then again a reference. And then in addition to the commit message, we will also see some lines which list the files that have been modified by the commit. So in this case, the file txt has an M here before, which means that it has been modified in this commit 84. And the file mistake.txt has the name sorry, the letter D, which actually means that it has been deleted in this commit. If one wants even more information, then one can use the option stat, and then for even further information, then the option minus P. Okay. So by default, Git log is going to give all reachable references which are on the same branch that the reference is on. But we can also use it to visualize different branches that have been created in the repository. And the option for that is --all. So this is going to display all the branches that have been created for this repository. And together with the option --graph, so what Git log --all is particularly useful with this additional option --graph, which is going to give it a nice visualization in text form of the different branches. So what graph does actually is going to add all these asterisks and delimiters or lines so that it can so that it shows the connection between different commits. So in this case, F0 is a merge commit, which Brigitte introduced, and using graph, then we can see that there are two parents of this commit, the A11 and the D3 one, and yeah, in its turn, those commits have a common parent, which is this initial commit 23. So Git log together with graph and all, and the one line, so that we have one line per commit, is very useful in displaying a concise summary of the entire commit tree. Okay. In addition to the Git, in addition to the Git log command for investigating the commit tree, there is another important command that displays even more information, and that is Git ref log. So Git log only displays the information that well, only displays the changes that have affected the commit tree. But if for example, we have some commits that are not reachable by any reference, then the reflog is very useful. Okay, it's going to become a bit more clear as I give you an example. So when does Git store information in this reflog? So whenever the tip of the branches or other references like the head or tags or branch tips are modified, then the reflog is going to be updated. You can merge the information of the Git log together with this reflog by using this option -G. But let's actually go through one example to clarify what this reflog is all about and when it is useful. So let's assume that I have created a commit. So I'm just editing a file or adding this content in a file, txt. I commit this change. So the -A option tells me that I will add all modified files to the index or staging area, and then I'm going to commit these modifications with the message I'm going to delete this. So this commit -a -m, this command -a -m is a composition, of git add and git commit. So then I have one commit, which is this 2F commit. The head is pointing to this commit and also the tip of the master branch. And then the commit message is I'm going to delete this. So let's assume now that I actually changed my mind and I did not want to do this commit. I want to simply discard this commit altogether. And the way I can do that is by using the git reset command. And what I need to specify as options to the git reset command is, okay, to which commit do I want to reset to? And the reference I can use in, or I use in this case is head tilde. And what this means is so head tilde is the commit, the parent commit of head, simply. So the parent commit of head is head tilde. So I want to revert back in time to the state of the repository at head tilde. And together with the option --hard, I'm going to discard all committed and, I'm going to discard all staged and unstaged modifications that I have in the working directory or the working tree. They are all synonyms. I discard the staging area, I discard the modifications in the working directory, and I reset the state of my working tree at the point of the previous commit. Then if I use git log again with this option one line, I see that this commit is no longer shown. So I lost all references which are related to this particular commit. And the only thing I see is that the head is pointing to this previous commit, that was head tilde, and also the master branch has been, so the tip of the master branch has been moved from 2F to this previous commit that I had. But is the commit really gone from our Git repository? Well, we can still find it in the reference log. So if I do git ref log without any particular options as start, and then it's going to assume that, okay, the reference I am considering is head, then I see a list of all the commits that have modified the reference to the head. And that is, from the oldest to the newest. So I had the initial commit, then modified the head to point to this initial commit. And then I had a second commit that moved the head reference to 2F, as we had seen higher up. And then I have done git reset to move back to the 23 commit, and that also changed the head reference. So then I have this. So the head reference moved back to 23, which that is what the head tilde stands for when I have executed the command. Okay, so the commits are still there in the ref log, but we do not have any references to those commits. So we can only refer to those commits by using the hash. So as this is a little bit complicated, I'm going to open up for questions and see if there is anything that you would like me to explain in more detail. If all is clear, you can give thumbs up. If not, thumbs down. It will be useful to know if it was more or less clear or not. Okay, then let us move on to how we can actually compare different commits. And the way we can do that is by using the git diff command, which we have used in a different context yesterday. But now we will use it with the commit hashes as options. So assume again we have the same repository with initial commit, then we created an additional branch, this second branch, and then we merged these two branches again in this merge commit. Now, if I want to compare the initial commit with this hash 23, and then this second commit, which is still on the master branch, so then I can simply specify git diff with the two hashes of the commits, or it can also be different references for these commits. For example, 23. So instead of specifying this commit hash 23, I could in principle refer to it as the tag that I have used. So it is possible to use other differences as well. But let's just look at it. Well, in this case, it has been defined using the commit hashes. So then the information, well, the output that git diff gives is a little bit overwhelming at the beginning, but I will explain to you what it does. So remember from Brigitte's lecture that all the different files and all the modifications that you have done to the files are going to be given a blob in this hidden Git directory. So if we have staged the file or committed the file, then all these modifications will have a blob. Now, when I specify git diff with these different hashes, then it's going to be, then Git is going to compare the blobs which are associated with these two commits. And then it's going to basically look at the blobs. Well, it will identify that in these different commits, there is one file that has been modified, and that is the file txt, and it has two different blobs in these different commits, and the hashes associated with these blobs are these ones. This is just a number which describes the file permissions of this particular file txt. It's not so important, but in this case, it just means it's a regular file. So no need to worry about that. But then it's going to compare this file in these two different commits, and then it will output what the difference is. So in this line here, which is called hang header, but you don't need to remember that, it's going to, so Git is going to list in which part of this file txt are there changes in these different commits. And then this minus here stands for the first commit I have specified here. This plus is going to stand for the second commit I have specified here. So then what it means is, okay, in the first commit, which in this case is this one, the file has been modified in the first line, and then in the second commit here. So there is a modification. Actually, a modification starting with the first line, but then there are the two upcoming lines which are different. Okay, it's a little bit tricky to explain, but so in this case here, I have simply an additional line in the second commit, the diff commit, that has been missing in the 23 commit. Okay. This was a simple example. There was only one file that has been modified, but if I have commits which modify many different files, then I can investigate the changes introduced one file at a time. And then in addition to specifying the hashes for the commits that I want to compare, I should add the option -- and then the name of the file that I want to compare in different points in time, as snapshotted by those commits. So then, in this case, the information is exactly the same as before, as this has been the only file that has been modified. So this is how you can use Git diff together with hashes. But remember from yesterday that Git diff can be used to list changes in the working tree, or synonymally working directory or workspace. It's referred to in different ways depending on the literature that you are reading or manuals you are reading. So if you want to see all changes that you have done in your working tree or working directory which are not yet committed, then you can show that by using Git diff head. If you only want to see changes that you, for example, have not staged yet, then you can use the git diff command. So this is going to show you the difference between the working tree or working directory and then the index or staging area. Now, if you want to see all the changes that you have changed, that you have staged, so showing the difference between the head and the index or staging area, then you can use the command git diff cached or the command git diff staged. So they output the same thing. So depending on actually how you use the command, which options you are specifying with it, you can get very different information. And it's all useful, but it can be really tricky at the beginning. Okay. Now, how we can navigate the commit tree. So we've seen that we can output all the history of the commits with git log or the ref log. But if we actually want to get to different points in time and check the files, not just seeing the differences, but go back in time to a certain commit, then what we can do is to use the git checkout command and sometimes git reset. And I will explain when one should use either of the two. But let's assume, again, we have this commit tree with these two branches. And what we want to do is to go back in time at this particular commit. We want to investigate, okay, which files we had the commit, what their content was. So we can use the git checkout command followed by the reference to that commit. And that reference, well, in this case, we only have one reference, and that is the commit hash. So I can use git checkout followed by the hash of this commit. And then what happens? So before we use git checkout, the head was pointing to this latest commit on the master branch. When I do git checkout, the head is actually moving. So it's moving and it's going to point to the hash that we have specified as a reference for git checkout. So head is pointing to this d3 commit. And if I do a git log, I'm going to see the commit that head is pointing to, and then all commits which are reachable from that point. So all ancestors of this commit to D3. And then in this case, well, D3 only has one ancestor. It's this parent commit 23. So git log will only output these two commits. So all these other commits, so for example, the F0 commit on the master branch is no longer visible here. And that is because git log only shows parent commits or ancestor commits, but it doesn't show child commits, so commits that have been introduced after this particular one. So it's back in time, but not in the future. Okay, so then again, as this is important, git checkout only moves the head reference. So head is pointing now to this D3 commit, but then the tip of the branch is not modified. If I were to do this git log command again, so I see that this reference to the master branch is still there for the F0 commit, but it's only the head reference that has moved. So this is important to remember. So git checkout should be used with care in the sense that if you have modifications in your working directory, git checkout will try to keep them when you are moving the head to a different commit, but it will also complain if and actually fail to check out to a different head if there are files in your working tree which have modifications and they have been also defined, or well, there is a block for them in the commit that you are trying to check out with. So as a good practice, I would say that whenever you do a git checkout or a git reset for that matter, it's important that you do a git status first and see what is the status of your working tree or working directory. Do you have modifications? Are they staged, not staged? And if you do want to do git checkout, it's typically best to do that with a clean directory. So in a sense, meaning no modifications in your working tree. With some exceptions, I would say, so you can safely do git checkout if you have new files that you have in your working directory, which were not part of that older commit. Then git checkout will always work. Okay, so I will just finish this part, and then we are going to call it a day. So one very common issue that can arise when you do git checkout is that you enter the situation of a detached head. And what does this actually mean? So in simple words, it just means that the head reference doesn't have any branch reference anymore. So initially, let's say that we had this situation, 3 different commits. The head was pointing to the latest commit, C. Also, the master branch was pointing to this commit C. If I were to do a git checkout back in time, so this commit A, well, with a hash T3 here, then what I'm going to do is move this head reference to the commit A or D3. But again, the master branch reference stays and points to the commit C. But then I'm going to, so doing the Git checkout, I'm going to get a warning from Git saying that, okay, now you're in a detached head state, but you do not have any branch reference. So this again, oh, sorry, we were moving to B. Oh, sorry, this is not super clear. One may disable this warning for the detached head unless you are very experienced and you know when you are in a detached head state. I would just suggest that you do keep it. So yeah. But let's assume that, okay, I move back in time with Git checkout to investigate that commit D3, but then I actually want to go back to the tip of my master branch. Then I can simply do Git checkout with the reference for the branch, in this case, master. So then I'm going to move back to this commit 23. As we had a bit higher up. Let's see. So yeah, I checked out this commit, but then I moved back to the tip of the master branch. Okay. So then I think we'll take questions if there are any, and then we are going to continue with other commands tomorrow. Other commands for checking the archaeology of the commit tree.